Hello and welcome to another video. Today's video is going to be Trigonometry 5 on Identities again. So I'm going to do Identities 2. But yeah, this is an extension of Trigonometry 4, which was on Identities, and we're going to be using some of the concepts we applied there into some newer concepts. So, topic 1, as always, is a review. Now, in the last video, we found out a few things. We proved that the cosine squared of theta is equal to 1 plus the cosine of 2 theta over 2, and that the sine squared of theta is equal to 1 minus the cosine squared of theta over 2. Or sorry, cosine of 2 theta, my bad. We also used these to solve some problems. So let's take the following integral, the integral of the cosine squared of theta d theta. We can solve this by first replacing the cosine of theta with 1 plus the cosine of 2 theta over 2, because we already showed we could do that up here. We pull out the 1/2, so we're left with the integral of 1/2 plus cosine 2 theta over 2 d theta. We can separate each of these into their own integrals. So we have the integral of 1/2 d theta plus the integral of cosine of 2 theta over 2 d theta. We'll move the halves out of each equation. So we'll have 1/2 the integral of d theta plus 1/2 the integral of the cosine of 2 theta d theta, like so. We can do a u substitution here, where u is equal to 2 theta, and du over 2 is equal to d theta. It's a little shortcut, or you can put it underneath the du and differentiate. We plot these out. So the first one, if you have nothing in the integration, it just becomes the variable. So instead now we have 1/2 of theta plus 1/2 the integral of the cosine of u du over 2. We add the 2 to the other equations, so we add the 2 to the 1/2. So we have 1/2 of theta plus 1/4 the integral of cosine of u du. We can integrate, so then we have 1/2 theta plus 1/4 sine of u, and then we plug that back in, so our final answer is 1/2 theta plus 1/4 sine of 2 theta. And you can see how we can apply these different identities to help us solve problems. Now, moving on to topic 2, we are going to do a little difference from these identities, but it's still useful to help us with some other stuff. So topic 2, we're just going to be expanding one of our identities. So as you can see, we already established that the cosine squared of theta is equal to 1 plus the cosine of 2 theta over 2. Now what we can do is we can square root both sides, so we'll have the cosine squared of theta is equal to the plus or minus square root of 1 plus the cosine of 2 theta over 2. Technically, you would have to keep the plus and minus up for all these steps, but in this case, we're just going to take the positive, just for this example, since the negative doesn't really matter here. We can square root the left side, so we're left with the cosine of theta is equal to the square root of 1 plus the cosine of 2 theta over 2. And we can use this to help us find more specific answers for cosines of certain numbers. Let me give you an example of that. Let's say theta, in this case, is equal to 15. So we would have the cosine of 15 being equal to the square root of 1 plus the cosine of 2 times 15, because it's 2 theta over 2. So you get that the cosine of 15 is equal to the square root of 1 plus the cosine of 30 over 2. That is a big zero. Now, we know from previous experience that the cosine of 30 is equal to the square root of 3 over 2. So we're going to replace that here, divided by 2. And then, because then we distribute the 2 between each function. So we're left with the cosine of 15 is equal to the square root of 1/2 plus the square root of 3 over 4. And this seems like a more complicated way of saying the cosine of 15, but these numbers are infinite decimals. So as a similar example, if somebody asked us for pi, instead of writing, like 3.1415 for the value of pi, instead of just saying pi, if they need that to a further decimal, they're not going to really get that from this. This lets us break it down and keep it to a further decimal. Just a small, quick example of what we can do with some of these identities. Now moving on to topic 3, our final topic of the video. This is on the product to sum formula. Product to sum formula. Now, as we can recall from our previous videos, we found that the cosine of theta 1 plus theta 2 is equal to the cosine of theta 1 cosine theta 2 minus the sine of theta 1 sine of theta 2. Now what we're going to prove is that the cosine of theta 1 cosine of theta 2 is equal to 1/2 bracket cosine of theta 1 plus theta 2 plus the cosine of theta 1 minus theta 2. We're going to prove that these two things are equal. Now we're going to work backwards for this proof. Instead of going from here and getting to here, we're going to work backwards and we're going to start from here. So if we take this equation, we can expand it out using this and some of our other ones, remembering that also the sine of theta 1 plus theta 2 is equal to a different version of this, but we'll get to that in a minute. Now, we can rewrite this as 1/2 bracket, and then we'll explain this out. So cosine theta 1 cosine theta 2 minus sine of theta 1 sine of theta 2 plus, because there's a plus here, cosine of theta 1 cosine theta 2, and then because there's a negative here, we have to invert this sign. So it would be plus the sine of theta 1 sine of theta 2. And that's how we would expand this out. Now, if we look at this more carefully, we will see that there is a negative sine of theta 1 sine of theta 2 and a positive sine of theta 1 sine of theta 2. So these, in a sense, cancel themselves out, and then we're left with 2 cosine of theta 1 cosine of theta 2's, and we will write that as it is. We'll write it as 2 cosine theta 1 cosine theta 2, and then multiply by the 1/2, and we're just left with cosine theta 1 cosine theta 2. Now this works for a multitude of other examples. I might get a different page out here so I have a little bit more room to write these other two. Let's say instead we proved that the sine of theta 1 sine of theta 2 was equal to 1/2 bracket cosine of theta 1 minus theta 2 minus the cosine of theta 1 plus theta 2, like so. Now we can prove this in a similar way. We will expand it like we did before. The expansion is going to be a little different, even though it's like both cosines, the negatives and positives are flipped, so we have to do a little bit more work when it comes to that, but not by much. We will find that it expands to cosine theta 1 cosine theta 2 plus, since it's negative, plus sine of theta 1 sine of theta 2 minus the cosine of theta 1 cosine theta 2 minus the sine of theta 1 sine of theta 2. Now we have a positive and negative cosine theta 1 cosine theta 2, so these cancel out. And then we have a positive sine of theta 1 and a negative, or positive sine of theta 1 sine of theta 2 and a negative sine of theta 1 sine of theta 2. But because there's an extra negative here, we could basically say that this is another positive. So then instead we'll just be left with 1/2 bracket sine of theta 1 sine of theta 2, 2 sine of theta 1 sine of theta 2, and then that multiplies out to sine of theta 1 sine of theta 2. Now we're going to do this with one more example because it's a little bit more of a complicated example. We're going to be proving that the sine of theta 1, sine of theta 1 cosine of theta 2 is equal to 1/2 the sine of theta 1 plus theta 2 plus the sine of theta 1 minus theta 2. And this is basically the same as the cosine of theta 1, cosine of theta 2, except these are now sines. Now again, we expand. So we have 1/2 bracket sine of theta 1 cosine of theta 2 plus cosine theta 1 sine of theta 2 plus the sine of theta 1 cosine of theta 2 minus the cosine of theta 1 sine of theta 2. We have a positive cosine of theta 1 sine of theta 2 and a negative cosine of theta 1 sine of theta 2. These cancel out, leaving us with 1/2 times 2 sine of theta 1 cosine of theta 2, which multiplies out to sine of theta 1 cosine of theta 2. Bye, guys.